Hey everyone, welcome to Code Harmony. Today we are going to cover a very important mathematics topic, which is Pascal's triangle. This video I am covering this Pascal triangle as a topic and what is this all about. Also, what is the significance of Pascal triangle in terms of problem solving and DSA. So I am going to cover this topic in terms of we all like who are getting started with the problem solving in DSA, in terms of preparing for interviews, going and solving problem on LeetCode, all of these. So let's get started. What is the Pascal triangle and what is the significance in terms of problem solving in DSA? Okay, Pascal triangle is a triangular arrangement of numbers where the top row starts with 1, and after that each number in the Pascal triangle is the sum of two directly above numbers. Also, the edges on each rows are always 1. So this is how the Pascal triangle look like. First row. Note the first row. We also have a look on this. We have n rows in this Pascal triangle. N rows in this Pascal triangle where rows are starting from 0. So this first one is 0th row, and it is the first row, second row, third row, fourth row, and so on. And in this row we have multiple elements. That elements are usually called kth entry. Kth entry in nth row. And this is first entry in second row, because k is also going to get started with 0. K greater than equal to 0, less than equal to n. So in second row, this is 0 and this is 1 and this is 2. K is going from 0 to 2. So this is our Pascal triangle. See how it is created. First row is having 1 and second row is having sum of previous 2 or 2 directly above numbers. There are no 2 directly above numbers. So there is no number we can write. But every edge, every row is going to get started and ending with 1. So second row starting with 1, ending with 1, there is no number coming from sum of above 2 numbers. Okay. Now in the second row, this is the 0th row, this is the first row, and this is the second row. In the second row, each number is the sum of 2 directly above numbers. So here it can be the sum of these 2 directly above numbers, 1 plus 1, 2. But every row is starting and ending with 1. Now let's try to build the third row. 2 directly above numbers, sum is 3. 2 directly above number, sum is 3. Starting and ending with 1. This is how the Pascal triangle is created. Starting with 1, 3 plus 1, 4. 3 plus 3 is 6. 3 plus 1 is 4. And ending with 1. And this is the Pascal triangle. Okay. So here we are clear that what is this arrangement, how this arrangement is created. Top row is starting with 1. Every element is sum of directly above numbers. Sum of 2 directly above numbers. And each row is starting and ending with 1. So this is how we have to keep it in mind to prepare this Pascal triangle. So we do not require any input. If someone asks me to create n rows, I can directly start building it. Like first row is always 1, then every row starting and ending with 1, and the middle elements are sum of previous 2 elements. So n rows starting from 0, kth entry starting from 0 to n. This is going to be the formula. So here if I generalize this formula, that nth row and kth entry, let's have a look on this. If I pick this 3 element in third row, this is the third row. So n value is 3, and what is the value of k? 0, 1, 2, 3. K value is 2. So 3, 2. 3, 2. Third row and second entry. What is this value? And this value is sum of previous 2 elements. and it is definitely be coming from 1 plus 2. 1 plus 2. And what is this one? 0, 1, 2. Second entry in second row and first entry in first row. So first entry, currently I am at second entry. Okay, so I will go to first entry. So 2 minus 1. And which row? Second row. From third to second row. 3 minus 1 plus again same row, row number 2, but the entry is 2 again. 2 and 2. So it is 2. So this is the same formula. So this formula can be applied, and this formula is known as Pascal's rule. So Pascal's rule is applied, which means that this 6 is coming from the sum of these two values. Okay, so we have created the Pascal triangle, and you are clear that what is this all about. Now what is the application of this Pascal triangle? Because we will be ultimately solving coding problems in the interviews. So applications, I have picked up two applications. First one is binomial expansion. Second one is combinatorics. Combinatorics is more important according to me, because I have seen this being applied in multiple coding problems. But we'll just try to get an idea. What is a binomial expansion? You guys must be aware of a formula that a plus b whole square is equal to a square plus b square plus 2ab. If I write it like this, x plus y whole square, I can write something like this: x, y, x, y, x, y. X with power 2, y with power 0. X with power 1, y with power 1. X with power 0, y with power 1. So this is usually these kind of expressions are expanded, and with these values I am going to put Pascal triangle values. The power is 2. Let's go to the second row. Second row is 1, 2, 1. I'm going to pick 1, 2 and 1. Put 1 here, 2 here, 1 here. And now our formula is ready. This is a square, this is 2ab, and this is b square. Okay, x plus y whole square is 1 in x square, 2, not ab, here should be x and y, 2 into xy and 1 into y square. So these values 1, 2, 1, these are coming for Pascal triangle. Okay, to make it more clear, let's try the x plus y whole cube. The formula we already know, that it is x cube plus 3x square y plus 3xy square plus y cube. But if we try to write it in terms of Pascal triangle, it is something like this: x, y, x, y, x, y, x, y. This is the third row. Third row is going to have 4 elements. This is the third row, going to have 4 elements, 0, 1, 2, 3. And these are those 4 elements. So x raised to power 3, y raised to power 0. X raised to power 2, y raised to power 1. X raised to power 1, y raised to power 2. X raised to power 0, y raised to power 3. Okay, this it's clear. And write the coefficient 1, 3, 3, 1. These values are coming from third row: 1, 3, 3 and 1. Now our formula is ready. So x plus y whole cube, this is the formula. And this is how this binomial expansion is being done using Pascal triangle. So here we have written something like this: whole cube. We can also create a general formula: x plus y raised to power, let's say, a. So we can expand this one as well. This was one application. We have studied it, but I have not seen it quite frequently in coding problems. But yeah, this combinations is very important. So I'm going to put more focus onto this. So first application is binomial expansion, a plus b whole square. This is also represented by Pascal triangle. Second one is combinatorics. Combinatorics means combinations. We are given n items and we have to take k items at a time. From n items, if we have to pick k items, it is also known as NCK combinations, right? We must have studied in mathematics permutations and combinations. Permutations is like arrangement, NPR. Combination is like picking up R items from n, NCR. So this combinations we are talking about. Okay, so in terms of combinations, we are having n items, we are taking k items at a time. See, n is my row number, k is my kth entry in that row, and that value will be represented by NCK. So nth row and kth entry, whatever the value present at this item, this is actually NCK. So this is the application. Now NCK is equal to nth row and kth entry from the Pascal triangle, and this is the formula. Formula we already know. And this is n factorial divided by k factorial n minus k factorial. Okay. If it is not clear, I will explain it with an example. Let's say we are talking about 3C2. So what is this 3? We are mapping it to NCK. N is nth row. And rows are starting from 0. 0, 1, 2, 3, 4. So 3 means third row. So this is the row and this is 2. 2 means second entry. Entry is also starting with 0. 0, 1, 2 and 3. So this is the value coming at 3C2. Third row, second entry, which is 3 actually. But if I try to apply the formula of combinations, it is 3 factorial divided by 2 factorial and 3 minus 2 factorial. 3 factorial is 3 into 2 factorial divided by 2 factorial. 3 minus 2, 1 factorial. 1 factorial is 1. 2 factorial, 2 factorial cancel and it is 3. So the value is 3. Okay. So here, what is the use? What is the use case? Let's say Pascal triangle is given to me and someone asks me to get the value of NCK, or in terms of combination, let's say directly, and we are using NCR because usually it is represented by this. Get the value of NCR. If n is within the range of these rows and r is within the range of these entries or within these rows, if we have the Pascal triangle, we can directly go to the nth row and rth entry. We directly have the value. In short, if we have the Pascal triangle, we can give the NCR result in order of one time. But you must be wondering that this formula is also order of one time. No, this formula is n factorial. N factorial divided by r factorial n minus r factorial. So factorial is being used. And factorial you already know. The factorial n factorial is n factorial time complexity. This is not open. This is like complying the formula but then figuring out the n factorial. And factorial of n is order of n time operation. Okay, so in short, what is this value? This value is 4th row and 0, 1, 2, second entry. This value is 4C2. So this is how this is useful in combinatorics. So let me give you a quick revision again. We started with Pascal's triangle. What is a Pascal triangle? In mathematics, it's a triangular arrangement of numbers where top row is starting with 1 and then all the rows starting and ending with 1 and the middle elements are the sum of previous two directly above elements 2, 1, 1, and it is 1, 2 and 3, 2 and 3, 1. So this is how the Pascal triangle is created. And after that, we looked at the applications. We had a look on the two applications, binomial expansion and combinatorics. So binomial expansion is something like a plus b whole square whole cube and power k. So that expression can be expanded. And the second one is combinatorics. Combinatorics is from n items, I have to pick k items. So what is the value? From that value is same as the value in nth row and kth entry. Kth entry in nth row. So it's same thing. So in short, the Pascal triangle is like a DP for combinations. And this is also going to be useful when you are coming to DP, numbers DP, and solving problems on LeetCode. So that was all about Pascal triangle. Just to utilize some time, let's pick this problem, LeetCode 118. LeetCode 118. And in the LeetCode 118 problem, we are given n. N is equal to, let's say, 5. It means return first 5 rows of Pascal triangle. So given is an integer value, and return, what we have to return is a 2D data structure where first 5 rows are available. So first row is 1, we already know. Second row is 1 1. Third row is something we can apply Pascal rule. Pascal rule is this one. Kth entry in nth row is equal to k minus 1th entry in n minus 1 row plus kth entry in n minus 1 row. So this formula is Pascal rule. Okay, Pascal rule I'm applying. 1 plus 1, 2 and 1. 1, 3, 3, 1, 1, 4, 6, 4, 1. Row 0, row 1, row 2, row 3, row 4. And row 5 is something we have to find out. 1, 5, 10, 10, 5, 1. So this is the fifth row. And we are going to be given an integer. And what we have to return is we have to return this in a data structure. Or maybe list of integer. So this is something we have to return. So here it is clear that we are always going to get started with 1. Let's say we have 1. First row is always ready with us. The second row is something, first 2 items. First 2 items means this one plus this one. But there is no 2 items available in this first row. So no item in between 1 and 1. Always starting with 1 and ending with 1. And for the middle items, sum of previous 2 elements. Let's say for this 2. This 2 is 1 plus 1. Okay. So when we are at 1, we don't have to do anything. Let's directly put it in the list. When we are coming to the second row, we are starting with index 1 until the end in the previous row. So starting with index 1, we don't have anything. So nothing to add from the Pascal rule. But apart from Pascal rule, starting and ending with 1. Now apply the Pascal rule, starting with this row, this item. This item plus previous item is 2. And starting and ending with 1. Now index 1, starting with index 1. This item plus previous item 3. This item plus previous item 3, and starting and ending with 1. So this is how we are going to create the Pascal triangle. Now I will show you the code for this. Here this is the Java code that I wrote for the Pascal triangle to find out first 5 rows in the Pascal triangle. Okay, so first row is always 1. So I added in the answer. First row I already added in the answer, and then starting from 1 onwards, I am counting the rows. Row is always going to get started with 1. I got the previous row because previous row I'm going to put iteration. Let us say 1 to 1 is there. So in the previous row, I will start from index 1. 2 plus 1, 3. 1 plus 2, 3. Every row is starting with 1 and ending with 1. and middle elements are calculated using Pascal rule, and this is the Pascal rule, and then just adding it in the resultant array, resultant list, 2D list. I hope this is clear to you. You can just practice it, but I took it as a topic because it is going to be useful. All of these easy problems are not just to practice and submit directly. These are there to teach us some concepts, from DSA or core DSA concepts. Okay, is there any doubt? Then you can reach out to me in the comment section or in the Discord community. Thank you guys. Bye bye. Thanks for watching.